Okay, so now I have put this into perspective that we're going to be using it in a lot. This is called the unit circle, and the reason it's called a unit circle is it's one long. The radius that we carved this out is one long. This is technically x squared plus y squared equals 1. Now you can figure out all of these values, whether you're in a unit circle or not, when you have the information, but we'll be using this quite a bit, and you're going to find this quite handy. Before we go into this, as we notice, as we increase this angle here, maybe I'll make one little gradation in it. So there's alpha, we'll call this beta. So this is another Greek letter for angles that we use often. You'll notice that as beta approaches pi over 2, which is 90 degrees, so y, which is going up, is going to get closer to 1. So tangent of beta, as beta goes to pi over 2, is going to be going to, well, the y is going to be going to 1, and the x is going to be going to 0. Everybody knows, hopefully everybody knows that we can't do this. But for some reason, nobody ever tells anybody why. And I had a long philosophical debate one time with a guy, and he thought that dividing by 0 was kind of religious. And that may or may not be, but let me show you mathematically why we can't do it. In math, we have some rules that we all want to live by, and one of them is just the meaning of these symbols. If I say that 6 divided by 3 is equal to 2, what I mean by this is that 6 is equal to 2 times 3. These things mean the same thing. So if I say that, let us do this. Suppose that you believe you can divide by 0, and 5 divided by 0 is some number. I don't know what number it is. It's not a number, but suppose it was. We're just going to call the number c. If that's true, then it must be that 5 is equal to c times 0. However, this is equal to 0, because anything times 0 is 0. So this simply cannot be the case. And that's why we say that this is undefined. It has no meaning. There's one other argument you might want to make, though. And you could say, well, wait a second. 1 over 1 is 1. 2 over 2 is 2. Oops, sorry, 1. Duh. 3 over 3 is 1. Is 0 over 0 equal to 1? And, well, if that's true, then it must be the case that 0 is equal to 1 times 0. Hey, wait a second. This is true. Here's where the problem comes in. 0 is also equal to 2 times 0. 0 is equal to 3 times 0. Here's the problem. If you define this, if you let this go, you could say that 0 divided by 0 was any number. And imagine how you would feel if, somebody said 6 divided by 2 was anything. It wouldn't really make a lot of sense for us. So that's why you can't divide by 0, and a surprising number of people never tell their students that. It seems to me a reasonable thing to know. I will show you one other thing too, as long as we're doing this kind of stuff. As an instructor, something I've seen so many times. Be careful, just be thoughtful and careful. I've seen people do this. 1 plus x divided by x is equal to 1. And what they did is they just went bam, bam, and this is left. Obviously, it is kind of funny, but here's why you can't do this. Suppose you did this. 1 plus 5 over 5. This is obviously 6/5. But if you go bam, bam, this is equal to 1. Don't do that, please. Okay. So these functions, where are they defined? And it will turn out that cosine and sine are defined for every radian measure alpha. So sine and cosine, sine, and usually we do this sine x, because x is usually the variable, cosine x, and tangent x, so x is going to range over whatever value of alpha we might like. Part of the reason why it's a little confusing at this point is because when you're using the unit circle, these x's have different meanings, and that will start to drive you crazy. I'll try and clear that up in a second, but I just want to say that this sine x is defined for all x. For all x. Same with cosine. This is problematic. Anytime that our angle gets up to pi over 2, or if it's down here, the same thing would be happening, 3 pi over 2, we have these problems. So tangent x is broken up anywhere that the angle is some factor of pi over 2 or minus pi over 2, which is of course 3 pi over 2. I'm going to put pictures of sine and cosine up now when we're using as x as the variable to see how this differentiates from this picture. These graphs I'll show you probably a lot. It's really important to know how to draw the basic versions of them. Let's do cosine. Well, actually, I'll put them both on the same line. So first off, here is your usual grid. Here's the x-axis. Here's the y-axis. And now, the x-axis is in terms of radians. And the y-axis is just a scalar. It's just a number. Incidentally, sine x and cosine x are bounded between plus and minus 1. That is, sine x is never bigger than 1, and it's never smaller than negative 1. Same thing with cosine. Here is pi over 2. Here's pi. Here is 3 pi over 2. Here is 2 pi. Here is negative pi over 2. Here is negative pi. Negative 3 pi over 2, and I'm going to need a little more, negative 2 pi. You should be able to recreate these graphs reasonably well, reasonably soon, because it'll be very handy. There are certain values of sine and cosine that you just need to know. As a matter of fact, I'm going to put them up here. I hope you'll write them down. These things you just need to know, and that is cosine of 0 is equal to 1. And let's see, what am I going to do next? I'm going to go cosine of pi over 2, which is 90 degrees, is equal to 0. Cosine of pi is equal to negative 1. Cosine to 3 pi over 2 is equal to 0. And cosine of 2 pi is equal to, well, you already know that cosine, well, actually, you probably don't already know that. Cosine and sine are periodic functions with period 2 pi. They repeat as you go around the circle, which I'll demonstrate more. This is also going to be 1. So just from this information, this picture looks like this. At 0, it's 1. At pi over 2, it's 0. At pi, it is negative 1. At 3 pi over 2, it is 0. And at 2 pi, it is 1. Also, another thing about cosine is that it's an even function. And I'll explain that when we come back. We have to take a reset up break here. But so the first half of this function looks about like this. An even function, as you'll recall from algebra, means that when you rotate it around the y-axis, it looks the same. We'll be back in a second.